This is what a math channel looks like when you're trying to find a phantom misfire. It can be really helpful, but maybe you just want to see how much each cylinder is contributing. Maybe you have a lean misfire. Maybe it's, not a large full misfire. Maybe it's a partial misfire, if you want to call it that. But this is a speed check of each cylinder using a math channel, and it measures the Hall effect square wave signals and how fast they accelerate and decelerate, just like the chip inside the computer of that controls the engine. So in essence, you can create a misfire monitor using the crank position data, and you'd have a signal identifier. So I use the coil number 1 trigger, or the secondary, as my identifier, so we know which cylinders are what. But I think most engines, you're going to find that the TDC mark is probably going to be number 1, but not always, and don't assume. So in this case, every cylinder is speeding up when air fuel is ignited, and you see an increase, decrease between power strokes. So there's going to be a time period where you don't have a power stroke, and that's what that looks like.